Outside of our basic gates of and, or not, we also have a few other extra items. We're going to start discussing those. The first one we're going to look at is called the XOR gate. And the XOR gate, you'll see it with the symbol of a plus sign circled, and then the drawing of it is an OR gate, but it has like an extra little line after it. And that's what our XOR gate is. XOR gate stands for exclusive OR. And it really is made out of the same principles that we have already talked about. It's just kind of applying them in a little bit of a different way. We may have an expression that looks something like X, Y bar, or X bar Y. And whenever we see this type of expression, we can change it and say that's the same as I'm having an A XORed with a Y. So XOR really builds off of our basic gates. So how does this XOR work? Okay, so let's make a little truth table. Our truth table is, let's do each piece on its own. Okay, so we have 4 options. Okay, so the first one, let's do this in blue. We're looking at X with a Y bar. So we're looking at when X is 0, these are going to come out to be 0. When X is a 1, we have potential for a 1. So we would see that I have a 1 and it with a Y bar. Y bar would be 1. That would turn out to be a 1. 1 and a Y bar here would be 0. That would turn out to be 0. Let's do the next one in green. Here I'm looking at X bar. So X bar, X is 0. The bar would be a 1. A 1 and it with 0 is 0. A 1 and it with a 1 is 1. A 0 with 0. And a 0 with 0. Okay, then we're going to put these two together and say X XOR Y, which is going to be our blue term ORed with our green term. So we have 0 with 0. That's a 0. 0 or 1. 1. 1 or 0. It's a 1. And 0 or 0 is a 0. With our XOR, a key item that we can kind of look at is the output is 1 if the number of ones entering is odd. So if we see here, these two items right here, we have an odd number of ones. And that will lead us to have our output of a 1. Okay, so let's look at some theorems we can use with XOR. Some of our theorems are, we can say X XORed with a 0 will produce X. X XORed with a 1 is going to produce an X bar. X XORed with X is going to produce a 0. And X XORed with X bar is going to produce a 1. And we also have the commutative property as well. You know, if I have X XORed Y as a term XORed with Z, that could be the same as saying A XORed with the term Y XORed with Z. So we have the commutative law Oh, that's associative law. Commutative law would be x XORed with y is the same as y XORed with x. Then we're going to have the distributive law. Distributive law would be if I have x ANDed with y XOR z, that would be the same as xy XORed with xz. All right, so those are the different laws that we can do. Now, along with XOR, we also have another type of gate called XNOR. And sometimes this is also called equivalence. And you'll see it be drawn out as an XOR with a circle at the end of the point. Or sometimes it'll be drawn out with 3 lines. So these are equivalents. And what these mean is if I say A XNOR with Y, that's the same as it being in our regular AND and OR gates, XY ORed with X bar, Y bar. So there's ways that we can move between these two items. Now, what's going to be useful for us to know are these equivalence pieces. So I know how an XOR is made up. And I need to know how an XOR is made up, because sometimes we'll see those gates being used in our Boolean expressions. So let's say we had something like B XORed with AC. And I want to take this, I want to change into AND and OR gates. Well, how can I do this? Okay, so let's take this and say it's X XORed Y. Okay, so I know it's X, Y bar, or X bar Y. All right, so let's say in our original equation, I was going to say B is my X, AC is my Y. So let's substitute in. So I get B AC bar or B bar AC. And then let's say I want to take this and I want it broken down a little bit more. So let's say I want it into sum of products. Well, right now, this is its own little gate. Let's just convert it down. With that item, we can do De Morgan's. With De Morgan's, I can say, all right, what I want to do is let me take the B. And if I apply De Morgan's into this area here, the AND became an OR, and then I get an A bar, C bar, plus B bar, AC. Then I can just multiply in the B. And then I'll get these two terms here with our final term. So there's ways that we can use these XORs being as part of our equation.